Today we're going to learn how to use MathCad as a tool to calculate uncertainties from lab data collected. So say you have this data sheet here that you have exported out from LabVIEW called test. So when you open test, you'll get our typical header here, and then you'll get your data. So in order to use this with MathCad, you need to take out the header. So I'm going to highlight the header area, and make sure you get this little comment one too. You don't want this coming in on the import from MathCad, so I'm going to highlight the area, right click, delete, select shift cells up, click OK. Now you can see the first row has starting my data. So I'm going to go ahead and save changes to that, and then when this little dialog box pops up, I'm going to hit yes, and I'm going to close it, and I'm not going to make any changes now because I've already saved it. Then I'm going to open MathCad. So MathCad is really good software. It's really nice and neat. You can do a lot of calculations with very little knowledge of programming since it's mostly visual based, which is very nice to use. So today we're going to need the matrix toolbar, the calculus toolbar, the Greek toolbar, and the symbolic toolbar. If you don't have these toolbars showing when you start up, you can go to View, Toolbars, and you can select the ones that you want. So MathCad is really cool how you can put in equations and symbolically solve it. You don't have to have actual values for that. I'll show you how to do that. I'm going to also show you how to symbolically solve these equations here. You symbolically solve differentials. And then I'm also going to show you how to import a data sheet and then apply an equation to it and get a resultant. So first things first is when you start typing in MathCad, you see this little blue bar, this little blue line. That means that it's a mathematical operator. So anything that's that value can be recalled mathematically. But when you finish, say I type and solve, then you hit the space bar, it turns to red with a single vertical line. That means it's now a text box. So I'm going to have solving symbolic equations. Solving equations symbolically. Let's say that. It's very good practice for when you write codes like in MathCad or MATLAB or whatever to put comments in. And the comments that I'm going to be putting in is basically this. And then you can also use a spell check built into MathCad itself to change whatever errors you have. So let's solve ln of phi equal to, now you can't put the normal equals in this one. You have to do the control equals. That's the shortcut to get this bold equals. You can also use the Boolean toolbar, and it's the equals on the Boolean toolbar. So we'll do ln of gamma equal to minus t over tau. And I'm going to solve this equation for tau. So in order to do that, I go to my symbolic toolbar, click solve, comma, and I'm going to put in the variable that I want it to solve for, tau. Hit enter, and you can see the green box around it means it's processing, and so does the light bulb by the little mouse, and then it gives me a resultant. So that's how you can solve equations symbolically in MathCad. So now let's symbolically take the derivative, take the partial derivative. And I'm going to take the partial derivative of the equation tau, which is this right here, with respects to gamma. So I'm just going to come over here, copy this, go to my calculus toolbar and hit dx, which is the partial derivative. And I'm going to paste in the equation that I just copied, and I'm going to put gamma here in the denominator. Then I'm going to go over here to this little arrow, which is a symbolic equivalent, or evaluate, and then it will evaluate the derivative. Now I can also change this to t, and then it will evaluate the derivative with respect to t of that equation. The dxn is the derivative to the nth power, so you can take the nth derivative. So this is how you can symbolically solve equations in MATLAB and MathCad and find partial derivatives. So now I'm going to import LabVIEW data. So to do that, there's a command in MathCad to do that, and that's called read file. So I'm going to name this a variable, let's say x, and I'm going to define that as read file. This has to be in capital letters. Then you're going to use quotes, and you're going to hit it once, and then both of them will show up, and you're going to type the location of the path of your object. So if I go to my computer, and then I navigate to the location of the test file on my desktop, which would be under C drive, then users, then my name, and then desktop, and then you look right here, and this is where the test file is. So I need to type in that whole path. So I need to go to local C, I need to type in C drive, users, Richard, desktop, then test.lvm, because that's the extension of the file, .lvm. So going over here, I'm going to start with C, then I'm going to type in users, and you need to type it with capital letters and everything exactly. My name, desktop, then test.lvm, and then next to it you're going to comma, another set of quotations, deeliminated. The reason why you need that is it's telling the type of file it is. Then if you click off of it, you see that it is kind of processing, and then it gives me a error because the file formatting spelling wasn't correct there. Now you can see it doesn't give me an error anymore, and it tells me it's good to go. So then I call this a variable x. I can just say x equals, and then it's going to give me out my matrix that I have there, and it's going to import that data that I had in Excel. And you can see that the first column is my time, the second column is my temperature. Now if I come over here and I want to separate these files, so I can say I want to get just temperature or just time, I can do that using a column matrix or a column call from the matrix. So if you go to your matrix toolbar, you can see here this M to the little less than and greater than equal to sign. It's called matrix column. What this does is it takes and isolates just that column. And as you notice here, MathCad default starts counting at 0. So the first column here is 0 and the second column is 1. So if I want temperature, and I'm going to call that T, a matrix T, I'm going to define that as my matrix column, that button right here, Control 6, or this matrix column button on the matrix toolbar, X, and then you put in the integer that it is. So it's 1, so I type in 1. So now when I recall T, it's just going to be the single matrix of just T. Now if I also want to have time come out of this, which I'm going to need later on, so I'm going to put in a little t and define it as the same way, but I'm going to say 0 instead of 1 because it's in column 0. And as you can see now, I got the matrices separated, so then it works. So this is how you can import data, and you can change and get the columns by themselves from the matrix, and then now you can use that matrix efficiently. So now I'm going to show you how to use this in a matrix notation to solve uncertainties all at once. So you have 76 different data points on this one. You guys may have thousands. So it could take a long time to calculate. I already showed you how to do this in Excel, but it's a little bit quicker with this in MathCad, which we're using right now. Now, if I wanted to use a different file, I could just type in, just change this file. So say you have multiple files with test 1, test 2, test 3. You could import this file again and change it to variables, and then you can do the same uncertainty analysis. Or what you could do is conduct the uncertainty analysis, save everything, and then just change it to test 1, and then automatically we'll do the uncertainty analysis again. So you set this up once, and then it will apply for your whole entire lab. That's the advantage of using this software, is it'll only take a few seconds once you set it up, and as you can see, it's like one line to get the file coming in, and then another little line to get the data by itself, and then one more line to get your uncertainty calculation put in, your uncertainty analysis put in, and then one more line to get it out. And you can see how easy it is to use this. So